Okay. So today we shall discuss about the kinematics chapter. So kinematics includes one dimension and two dimension kinematics. Okay. So we shall discuss about one dimension and two dimension kinematics. Actually, kinematics was a branch of physics where we discuss about motion of bodies. Kinematics is a branch actually. It's a branch of mechanics where we discuss about motion of bodies without reference to force. Kinematics is a branch of mechanics, and you know mechanics is a branch of physics. And here, if you draw a diagram like physics, okay, so in physics there is one branch called as mechanics. Okay, mechanics, optics, heat, electricity. Like this there are many branches. Among these branches again there are sub branches also, like along with electronics here, electricity, there is one more branch called as modern physics here. There is one more branch called as modern physics here. Okay, these are sub branches. And among this branch called as mechanics, again this is converted into two sub branches in which we shall discuss about kinematics and we shall discuss about dynamics also. Okay, so kinematics, as I said, it's a branch of mechanics where we discuss about motion of bodies without reference to force. You know that equation of motions we have discussed on. Equations of motion will be present in kinematics. Okay, V is equal to U plus AT, S is equal to UT plus half AT square. So in these equations of motion we never ever discuss about force. But gravitational force will be there. When a body is thrown upwards, it is going to fall down automatically. Gravitational force is present, but there is no contact between the force and the body. There is no contact between the force and the body. That's why we are not going to refer the force in the case of kinematics here. But if you observe dynamics, okay, so what are we going to do here? In kinematics, we are not going to discuss about force, no force. But in dynamics, we are going to discuss about force is discussed here. Because Newton's laws of motion we call it as. In every Newton's law, we are going to discuss about force. Every body continues its state of rest or of uniform motion until unless it is acted upon by a force. Action and reaction forces are equal and opposite. Acceleration is directly proportional to force but inversely proportional to mass. Second law, third law, first law. So in each and every law we are discussing about the force here. But whereas in kinematics we are never ever going to discuss about the force. What is the point now? So now we are going to discuss in details about kinematics. In kinematics we will discuss about first one-dimensional kinematics here. One-dimensional kinematics. So we shall discuss about what is this one-dimensional kinematics. So in this one-dimensional kinematics, now we shall discuss the basic concept here. You all know that there is one concept called as velocity. Velocity is called as a displacement by time. And you also know that speed is also present here. Speed is nothing but distance by time here. Speed is nothing but distance by time here. And you all know that velocity is referred to be a vector and speed is referred to be a scalar. Understand? Scalar. We will discuss about velocity when a body is going in a particular direction. We generally discuss about velocity of a bullet until unless if it is going in a straight line. Velocity we call it as. Bus. We don't call velocity of a bus. We call speed of a bus. Because at every step bus is changing its direction. But we call it as velocity of a wind because wind is in particular direction. Wind is in particular direction. When you throw a body upwards, it comes exactly downwards in a particular direction towards the center of the gravity. At that time we call velocity of a body. Velocity of a body moving towards the ground. So if any particular direction is there, we call it as velocity. If there is no specified direction, we call it as speed here. And displacement is also velocity. Displacement is also a vector quantity. Distance is not called as a vector quantity. As it is said here that this is your house and this is your school. From house to school you are going along with the road, okay, which is having different directions. This is the path of the road you are following here. And if you measure, this is going to be a distance, okay? This is going to be a distance. And distance is, let us imagine it is 10 kilometers. Distance it is in 10 kilometers, okay? Distance is 10 kilometers. But let us imagine that you are a rich kid. You are a rich kid who is having a helicopter or a drone. Human drones are available nowadays in countries like Japan. What they will do? They will just come in the terrace of their buildings and they will directly adjust the direction in a Google map that your school is here. So just the drone will move in a straight line like this. Because drone is moving in a sky where there is no particular direction or path. It may go straightly towards your school without any change of direction. And that's why this is called as displacement. Because distance is measured and is referred with a distance that is letter D, whereas displacement is referred with small distance S. Okay, distance S. Displacement is given with S and distance is given with D here. Okay, so this is the displacement here. How much is going to be the displacement? Displacement is only 6 kilometers because this is a long path. The straight line distance also is called as displacement. The smallest and shortest definition of displacement is the shortest distance is called as displacement. Is it? That's why this is called as displacement. Now, I'll give you one small example to understand better about displacement. Example number 1. Complete circle. Understand? Complete circle. What is the meaning of this? For example, you take a question. A man completes a circular path of radius 7 meters. Let us take 70 meters. A man completes a circular path of radius 7 meters. Then you call it as, then find the ratio of distance and displacement. Okay, so first question is a complete circle. So a man is going to start from one particular point. At this point, for example, this is the first point. He completes a circle and reaches the same point here. Then what is the ratio of distance and displacement? The solution is, okay, the ratio of distance and displacement. Distance means D, displacement is S. So this is radius R. What is your formula going to be? Distance means 2 pi R. And what is the distance here? Distance means, displacement means 0. Distance means complete. Displacement means, you should understand that it is a starting point and ending point. Starting point also there only, ending point also there only. That is going to be the displacement. The straight line distance from the starting to the ending point is also called as displacement. The straight line distance from the starting to the ending point is also called as displacement. And here if you observe, the starting point is the same and even the ending point is also the same. Okay, for example, this is the starting point. This is the same ending point here. So your answer is going to be how much here? It is going to be infinity. Okay, sometimes you lost the distance and displacement and distance ratio, then you'll write 0 by 2 pi r, which is equal to 0 here. Okay, this is the first question. First part of the question. Then what is the second part of the question in the same case here? In the second part of the question, if he is telling that, okay, half circle. If a man takes a complete, not a complete circle, only a half circle, then what is the ratio of distance and displacement? You can just take here, so this is a complete circle, but if you observe, this is the starting point of a man and he is going to reach the opposite end, which is going to be the ending point of a man. Then what is the distance and what is the displacement? See, now if you observe, this path along the circle he is going to move is called as a distance, and this is the path who is going from starting to ending point is called as displacement. Okay, so if you take a complete circle, the answer is s by d is equal to 0 by 2 pi r, which is 0. And if he is going to take only half circle, then the same formula will apply. Distance by displacement. Displacement by distance is nothing but, displacement is nothing but 2r, because r and r is going to be the diameter here. Half circle means exactly opposite ends, and that is going to be the diameter. Whereas the distance is nothing but half of the circle, no? So half of a circle means you can write complete circle is 2 pi r and half of that is pi r. Okay? So the ratio of distance, displacement and distance is nothing but 2 is to pi. 2 is to pi you can write here, is it? Understood all of you? 2 is to pi you can write like this. Okay? Now you just see here, the third question is 1/4 of a circle. 1/4 of a circle. For example, if this is a complete circle, a man moves only 1/4 of a circle. So here, this is the starting point and this is going to be the ending point. He is going to take a 1/4 of a circle like this. This is the 1/4 of a circle. Understand? Then, if it is 1/4 of a circle, then what happens? Let us see here now. So, if you observe this case, you are going to understand one thing, that this is going to be the distance here, and this straight line from starting to ending point is going to be the displacement here in this case. Okay. Then, you all know this is going to be a radius here. And our aim is to find out the ratio of displacement by distance. Okay, and you all know that distance in this case is the complete circumference by 4. Because 1/4 of a complete circle, area is going to be pi r by 2, is it? Pi r by 2 here, okay? And what is the displacement? If this is r, and this is 90, is it not going to be r root 2 by taking Pythagoras theorem? That's it. Then here, a displacement is going to be r root 2, and what is the distance? Distance is going to be pi r by 2, is it? Pi r by 2. So r gets cancelled. So s is to d is equal to 2 root 2 is to pi. Okay? Then, like that, the fourth point which we need to discuss here is, it is 1/6 of a circle. If it is 1/6 of a circle, then what happens? If it is 1/6 of a circle, you know that this is a complete circle here. Let us divide this circle into some points here, okay? I am converting this circle into a hexagon here, so that you will get a complete picture, a clear picture of what I am going to discuss here. This is a hexagon, is it? This is a hexagon having equal sides. Now, if this is a center, I am drawing one triangle here. And you all know that the angles of the triangle is going to be 60, 60 and 60. Okay. And you also know that this is radius, this is radius. Angles are same means length of the sides are going to be same here. Angles are same means length of the sides are going to be same here. Then, what are you going to do here? Distance is nothing but 2 pi r by 6. 1/6 of the circumference is going to be pi r by 3. Pi r by 3. And displacement is how much? Is nothing but r. What is this distance? Then you understand that this distance is r only if you completely convert the circle into a hexagon and divide hexagon to 1/6 of a part, which is going to be an equilateral triangle whose sides are going to be same. Understood? Next. Then the ratio of distance by displacement is how much? For example, first of all, you just divide. So it becomes simply for understanding here. That is r by pi r by 3. So S is to D is nothing but 3 is to pi. We shall discuss about average speed. Average speed. What do you mean by average speed here? You all know that the general formula for speed, okay, speed, we'll discuss speed as V. Speed is nothing but distance by time. But average speed is nothing but total distance by total time. And what is the total distance? Let us take total distance as d1 plus d2 plus d3 up to dn by t1 plus t2 plus t3 up to tn here. For example, a body moves a distance d1 in time t1, a distance d2 in time t2, a distance d3 in time t3 and so on. Okay. So now, what is the general formula here in this case? This is the general formula for average speed. Speed means distance by time. Average speed means total distance traveled by total time taken in each and every step here. Okay, so now this is the basic formula, basic definition. But now, how many types of average speeds are there? That is a big question for us. So this is the first average speed. In an average speed here, there are two types of average speeds. We shall discuss about the two types of average speeds here in details. First thing is distance average speed is there and time average speed is there. Okay, and in distance average speed, how many subcases are there again? There are two subcases here, case 1 and case 2. Do you know all these things? So we have to explain about this here now. So what is the meaning of distance average speed? We shall discuss in details about this distance average speed here. So in distance average speed, if you observe, one thing it is clear. For example, in distance average speed, I am taking case 1. Okay? In this case 1, let us imagine one thing here. What is that? For example, a body travels first half of the distance with the speed v1 and next half of the distance with speed v2. Okay? Let us continue like that only. For example, only two cases I am taking now. First half of the distance, second half of the distance. Remaining infinitely we are not going to consider. Only two cases we are going to take here. This much is given to us. Then how to find out the average speed? Okay, I'll give one small example for that so that it is clear. If a car travels first 30 kilometers with speed 50 kilometers per hour and next 30 kilometers with a speed 60 kilometers per hour is given. This one. So I'll tell you a small clue here. Here speeds are given. If you observe what is not present here, what is not given, what is not given, time is not given here, is it? If you observe, time is not given, but our formula is having time here. But this is the question where there is no discussion of time. So you can say there is no discussion of time. So when there is no discussion of time, there is one shortcut here. We have to prepare that shortcut. Understand? So this is not a solution, this is an explanation for a shortcut. This is an explanation for a shortcut. What is the shortcut? I will discuss here. Just see here. So the general formula is average speed is equal to total distance by total time here. But as there are only two cases, I am taking two distances and two times here. Okay? And you all know that V average, here there is no discussion of time. That's why we have to replace times here. You have to replace time. How are you going to replace? V1 is equal to D1 by T1. So T1 is equal to D1 by V1, T2 is equal to D2 by V2. What is the point now? So D1 plus D2 by T1 can be written as D1 by V1, D2 by V2. Okay? And you all know D1 is equal to D2 is equal to D by 2, because first 30 and next 30 is telling no. So 30 means in 60 kilometers is dividing the distances into two halves, 30 and 30. Okay, so what are you going to do now in this case? You just write here V average is equal to D by 2 plus D by 2, and this is D by 2 divided by V1 plus D by 2 divided by V2 here. Okay, so if this is the case here, then just common out this D by 2, you'll be getting 1 plus 1 here, and common out this D by 2, this is 1 by V1 plus 1 by V2. So D by 2 gets cancelled. V average can be written as 2 here, and this LCM is V1 plus V2. Oh sorry, can you write this as V1 V2? LCM as a product of the denominators, and this can be written as V1 plus V2 or V2 plus V1, what it may be. So the final answer is V average is equal to 2 V1 V2 by V1 plus V2. So this is a shortcut formula to find out the average velocity only when speeds are given. Average speed. This is the formula to find out the average speed only when speeds are given. Even distances are also not given, only is telling half and half in the question. Half and half. 30 and 30. Understand? Sometimes he may specify also like this. A bus is traveling first half of the distance with a speed 20 km per hour and next half of the distance with a speed of 30 km per hour. Then also he is not giving the distance, just telling distance, that's it. So if he gives us speeds, that is more than enough for us, is it? Okay? So what are you going to do now? This is V average is equal to 2 into, what is that? 50. Better you take 40. It will become easy for us to calculate, that's it. No other intention. 2 into 40 into 60 by 40 plus 60. It is 48 kilometers per hour, a shortcut. Just if you know this formula, you can solve this problem. Okay? Is it clear? Okay. Now, we shall discuss the next part of this question here. Next part, that is case 2. We shall discuss what is the case 2 here. Case 2 is the similar type of distance average speed only. In distance average speed, this is case 1 here. And what is case 2? Case 2 is, for example, this is point A and this is point B. If a body moves from A to B with speed V1 and returns from B to A with speed V2. Okay, then find average speed. Find average speed here. Okay, I will give this problem in the form of an example. Okay, just as I have given here in this case. So, a boy travels in a bicycle from house to school with a speed, how much? 6 kilometers per hour. Early morning will be having high speed. And returns from school with a speed of 4 kilometers per hour in the evening, because early morning he'll be in hurry, so that he has to reach the school, he is moving very fastly, returning back with a speed of only just 4 kilometers per hour. Then what is the concept behind this? One thing, it is clear that distance of while going, distance while returning is same, is it? And our formula says, this is an explanation here, shortcut you can say, our formula says that total distance is d1 plus d2 by t1 plus t2, and if you observe here, there is no discussion of time in this case also. As there is no discussion of time, there is only the discussion of distance here, that's it. That's what is called as distance average speed. Distance average speed, because there is a discussion of distance and there is a discussion of speed, but there is no discussion of time here. Time average speed means there is a discussion of time, there is a discussion of speed, but there is no discussion of distance there. Got the point now? So now let us see here what is going to happen here. You all know that d1 is equal to d2 is equal to d here. The same thing you will write now. First thing is you will write d1 plus d2 by d1 by v1 plus d2 by v2, because you have to replace times. As times are not present in the situation given in the problem, we need not take times here, so we can replace this one. So d1 and d2 can be taken as d here. So d plus d by v1 plus d by v2. So d if you common out 1 plus 1, here d if you common out 1 by v1 plus 1 by v2. So dt gets cancelled. V average is equal to 2 v1 v2 by v1 plus v2. The same formula we are getting. Formula is same but situation is different. Formula is same but situation is different here in this case. If a body moves first 1/3 of a distance with speed v1, next 1/3 of a distance with speed v2, and the third remaining 1/3 of a distance with speed v3, 1/3 of a distance. So d1 is d by 3, d2 is d by 3, and d3 is d by 3. If this is the situation, what is the formula is going to be? Can you imagine the formula? How much? How much it can be? You just write like this: average speed is equal to d1 plus d2 plus d3, and t1 plus t2 plus t3 is the basic formula, is it? But if you observe the situation, there is no discussion of time here. So we're going to do here, V average is equal to d1 plus d2 plus d3 by d1 by v1 plus d2 by v2 plus d3 by v3. If you are a good mathematics student, then you can just tell me the formula directly if you are good at mathematics. What is the formula? 3v1 v2 v3 by v1 v2 plus v2 v3 plus v3 v1, that's it. Okay? So here, what I am going to do? D by 3 plus d by 3 plus d by 3. This is d by 3 by v1 plus d by 3 by v2 plus d by 3 by v3. So d by 3 if you common out and cancel, what are you going to get? 1 plus 1 plus 1. 1 by v1 plus 1 by v2 plus 1 by v3. So if you do the simplification, 3v1 v2 v3 by v1 v2 plus v2 v3 plus v3 v1, you can write like this. Is a trick. This is the three cases of distance average speed. This is a three case distance average speed. Now we shall go in details regarding time average speed here. Okay, as I told that average speed is of two types. One is distance average speed, the other is time average speed. In distance average speed, we have discussed the two cases also. This is case 1 is present and there is case 2 is also present. But in time average speed, there is only one case, that's it. There are no multiple cases in this time average speed. What is that one case we shall discuss here? That one case is, for example, here, if a body travels half of the time with speed v1 and remaining half of the time with the speed v2. So first half of the time and the next half of the time, like speeds v1 and v2, then find the average speed. Okay, find the average speed. I will convert this situation into a problem and try to make you understand the question here. Okay, like for example, if a lorry travels first 2 hours with a speed of 40 kilometers per hour, and next 2 hours with a speed of 60 kilometers per hour. Okay, then find average speed. That's it. He will never specify to find out time average speed or distance average speed. Just he will tell average speed. That's it. And you have to recognize the situation here, which situation it is going to be. Then for that, if you observe, this is the case here. It's very simple. Our basic formula says that d1 plus d2 by t1 plus t2. But what is not discussed here in this case? Can you tell me now? No discussion of distance. That's why, what are you going to do? You can just replace v1 is taken as d1 by t1. So d1 is taken as v1 t1. And similarly d2 is taken as v2 t2. I have to replace distances in terms of velocity and time because it is not specified in the situation here. Got the point now? So what I am going to do here, let us see. Just I am going to write v1 t1 plus v2 t2 by t1 plus t2 here. And you all know t1 is t1 by t by 2 and t2 is also t by 2. So v average is equal to v1 t by 2, v2 t by 2 divided by t by 2 plus t by 2. Common out this t by 2, then what are you going to get? So v average is v1 plus v2 by 2. You are getting, that's it? Yes? So this is you are going to get. So the solution is very simple. That is, you have to find out average speed as v1 plus v2 by 2. That is 40 plus 60 by 2. That is how much? 50 kilometers per hour is your answer. That's it. Okay? Okay? This is called as geometric mean. This is called as geometric mean. And that is called as harmonic mean. Is it? Harmonic mean means 2 v1 v2 by v1 plus v2. That is harmonic mean. This is called as geometric mean. In means there are many types, no? In mathematics, did know? Don't know? Huh? Yeah? इसको arithmetic mean बोलते नहीं? Yes. Arithmetic mean बोलते हैं. What is the geometric mean then? Yeah. Okay, so that is harmonic mean. 2 v1 v2 by v1 plus v2 is harmonic mean. This is called as arithmetic mean. Average of all the numbers. That's it. Okay. So this is about average speed. Okay. So here we shall discuss about the equations of motion here. V is equal to u plus at. S is equal to ut plus half at square. V square minus u square is equal to 2as. Each and every equation is having certain speciality in this. Si is equal to u plus a into n minus half. Okay. So what are you going to understand here? These are the 4 equations of motion. If you observe the speciality of the first equation, what is observed here? There is no discussion of displacement here. The second one, there is no discussion of final velocity. And if you observe the third one, there is no discussion of time here. Okay? Okay. But fourth one can be recognized easily. Fourth one can be recognized easily here because it is an nth second. Displacement traveled in nth second can be easily recognized here. So in these 3 cases here, each and every equation is having certain meaning here. Certain meaning, if you understand. What is the meaning here? Let us see. Okay. So here, if you understand these equations now, 4 4 equations of motion. What is the derivation? Do you know the derivation of these equations? Once if you know the derivation, okay. So derivations should be learned because he will ask the problems in the middle of the derivations. He will convert the middle of the derivation as a problem and ask you. Then you should know the derivation. It's a very simple thing here. So I'll discuss about the first equation of motion here. V is equal to u plus at. How are you going to derive this equation? It's very simple here. Let us imagine a ball is having initial velocity u, and it moves with it moves certain distance here, and its final velocity is v here, and it has taken time t to travel from here to here. Let us imagine it is having a speed of 1 meter per second, and it has reached to a speed of 3 meter per second, and for traveling this from here to here, time taken is 2 seconds here. Then how to find out an acceleration? What is the definition of an acceleration? You all know acceleration is rate of change of velocity. Rate of change of velocity. Okay. So acceleration can be written as rate of change of velocity means what? Rate of change of velocity or change in velocity per unit time. This also is a definition. Change in velocity in per unit time. So you can write this as change in velocity by time. Then you can also write this as v minus u by t here. So therefore v minus u by t is equal to a. This implies that v minus u is equal to at. V is equal to u plus at. This is the first equation of motion. This is going to be the first equation of motion here. So you can write like this. This is the first equation of motion here. Okay. Next, we shall go for the second equation of motion. What is the second equation of motion? Second equation of motion is S is equal to ut plus half at square. What is the meaning of this? For example, a body starts with an initial velocity u, and it gains the final velocity v, and the distance travelled from here to here, displacement travelled is s, and time taken to travel from here to here is t. Then what is the formula going to write now here? So if this is the situation here, let us see what is going to happen here. You all know displacement is nothing but velocity into time, because velocity is equal to displacement by time here. But in this case, initial velocity is different and final velocity is going to be different here, as we have given the example there. And time is taken as 2 seconds. Let us imagine this is just to understand an example here. In this case, instead of writing velocity into time, you have to write the displacement as average velocity into time here. Average velocity into time here, because this is a distance time average speed. It is coming at a time average speed. So you can write V average as u plus v by 2. V average is initial velocity plus final velocity by time 2 by 2. Sum of the velocities by number of velocities. This is just like what is that? Arithmetic mean, you can say. So what are you going to write now? Displacement is equal to u plus v by 2 into t here. Okay, this is equation number 1. Can you write this like that? Like in such a way that substituting 1 with v is equal to u plus at. That is the first equation of motion what we have got there. Then in this case, s can be written as u plus v can be written as u plus at by 2 into time s t here. S is equal to, can you write this as 2u, and this is at by 2 into t. So if you multiply this here, you can write this as 2ut by 2 plus at square by 2. Partially I am dividing these two. So 2 gets cancelled. S is equal to ut plus half at square. So getting this equation here as the second equation of motion. Understood? Yes. Next, what is the third equation of motion here? V square minus u square is equal to 2as. How are you going to get this one now? If you observe here, let us take this as equation number 1. Okay, can you take this as equation number 2? Let us imagine. Okay, that is equation number 2. So here you can write like this. You can write from 1. From 1 we got v minus u is equal to 80. Let us consider this as 3. And from 2, what are you getting from 2 here? Can you write this as v plus u as 2s by t? Can you write this as v plus u is equal to 2s by t cross multiplication? Then what are you going to do? 3 into 4, multiply these two equations, we are getting how much? V minus u into v plus u is equal to a t into 2s by t here. T gets cancelled. A minus b into a plus b is a square minus b square is equal to 2as. You do not write the bracket here, you just write like this. B square minus u square is equal to 2as. So this is the third equation of motion we are getting here by using the mathematical expressions here. Now finally, we are going to discuss about this equation that is called as fourth equation of motion. So in this fourth equation of motion, let us consider a body. A body travels a distance traveled in 4 seconds. For example, here, from here to here, again from here to here. Let us imagine the two cases here. In this case, first, for example, a body travels from here to here. That is, displacement traveled in 4 seconds is this from here to here. Next, this is displacement traveled in 5th second is this much. And from here to here, if it is observed, displacement traveled in 5 seconds. If you take from here to here, you have to consider, is it? So 4 seconds, 5 seconds, and this is the 5th second. Then in this case, what are you going to do here? You just write the equation like this. Displacement traveled in the 5th second can be written as displacement traveled in 5 seconds minus displacement traveled in 4 seconds. Can you write like this? Yes? So displacement traveled in 5th second is equal to displacement traveled in 5 seconds minus displacement traveled in 4 seconds. Okay? So here in general you can write displacement traveled in nth second is equal to displacement traveled in n seconds minus displacement traveled in n minus 1 seconds. Can you write like this? Yes? Okay? So now what I am going to do here is, you know the formula S is equal to ut plus half at square. If you take t, if you replace t with n, what are you going to get now? You just write here S is equal to un plus half an square. Okay? So if t is taken as n seconds, because in the place of n seconds I am writing this, like Sn is equal to Sn seconds, means t replaced with n seconds here. In the place of t you write n here. Okay? So un plus half an square you are writing now. Okay? Now the second case is, if t is equal to n minus 1 seconds, then you can write this as t n minus 1 is equal to un minus 1 plus half a into n minus 1 whole square, is it? Okay? So what I am going to do here is, you just simplify un minus u plus half a n square plus a square plus b square minus 2ab. I just simplify this one. Un minus u plus half an square plus half a minus an. That's it. This is displacement traveled in n minus 1 seconds. Got it? Yes? So what are the equations getting now? This is for n minus n seconds and this is for n minus 1 seconds. Can you substitute these two equations here? Yes? Going to substitute these two equations in this case, what are you going to get now? Let us see. So displacement traveled in n second is equal to Sn seconds minus Sn minus 1 seconds here. Then if you substitute, what are you going to get? Displacement traveled in n second is equal to, n seconds will write this equation, un plus half an square minus, if you already substitute, minus if you simplify you are getting minus un, this is plus u minus half an square minus half a plus an. Is it? So what are the terms going to be cancelled here? un, half an square, half an square. So displacement traveled in n second can be written as u if you take here and plus an minus half a right here. That's it. That is the things. That are the terms which are left out here, is it? So writing now here, Sn second is equal to u plus a into n minus half. Or you can also write it as displacement traveling n second is equal to u plus half a into 2n minus 1. Like this also you can write here. Like this also you can write here. This is the fourth equations of motion derivation. Got the point now? Understood? Now, so if you see the graphs here, first thing is displacement time graph. Displacement time graph, or it is also called as position time graph. Okay, displacement time graph or position time graph. We shall discuss about this. So what is the meaning of these graphs? We shall discuss here. So you are going to consider this as a graph in x-axis and this is a graph in y-axis here. For example, now I am drawing one graph from here. This is the graph, a straight line. This is a straight line here. Okay? This is just the graph starting from one point and ending at the other point here. Now what I am going to do is, this I am considering it as xy now. So xy, yes. So displacement is this one and time is this one, isn't it? So this is time t1 from time t2. A body travels from t1 to t2. Starting point is t1, time is t1 and t2. But this is the origin of this graph here, 0, 0. And now if you observe here, this is taken as position displacement s1. And this is taken as position s2. Now if I draw a line here, and draw a line here also, this is taken as angle theta. Okay, so just take it as AB, C and D. Okay, so like this if you take, what are you going to get? Let us see here. So what are you going to understand from this type of graphs here? Now first thing is slope. What is the meaning of slope? Slope is nothing but axis. What is that? Slope. Slope is nothing but velocity. So velocity, if you want to find out from this graph, you have to take the slope of the graph here. Velocity, if you want to find out, slope of ST graph is giving you the velocity. Slope of position time graph or displacement time graph is called as velocity here in this case. So we are going to write the velocity. Velocity slope is nothing but tan theta. Tan theta is nothing but BC by AB. Okay, so BC by AB, which is nothing but displacement delta S by delta T. Or you can also take delta S as S2 minus S1 by T2 minus T1. Change in displacement will change in time gives you the velocity here. Okay, so this is velocity time graph. Slope of this graph gives you velocity here. Okay, you have to understand this one. Now, if you understand this one, you will understand the remaining things also very easily. I will give you some of the graphs here and tell me now, what is this graph representing now? First example 1. If this is a graph, which is called as displacement time graph or position time graph. Now, if I draw one line like this, what is the meaning of this graph? Can you tell me? Displacement is 0 here. That means body is at rest. Position is same, no? Time is increasing. You can say this is a dead body. Position is not changing, it is same. For example, from the origin, it is at 8 meters from the origin. And it is there itself. It is not going to increase. But time is passing away. Time is passing away. And if you want to judge this graph immediately, then you have to observe angle here. Because velocity is equal to tan theta, no? Okay, if you just observe angle here, immediately you'll get an idea what type of graph it is. How? You just see here. Here theta is equal to 0, no? What is theta in this case? 0. Theta is 0 means V is also 0. And when V is 0, V is 0 because displacement by time. 0 by something is 0 only. Displacement is 0, velocity is 0. Okay? So if you observe tan theta, then you can judge the graph very easily. I will give one more example of graphs here. I will tell you one more example. Now you just tell me what type of graph it is. If this is a graph, what is the meaning of this? Tell me. What is the meaning of this graph? Yes?
Distance increasing with time.
This graph represents uniform speed because displacement time graph. This is theta. Uniform speed. But it is difficult to judge the graph immediately, is it? How can you judge the graph immediately? I told you the clue is this one. The clue is this one. If you see this, it's very easy to understand. Here, if you want to judge the graph, you just take here theta is constant. Theta is same. Theta is constant. If theta is constant, V is equal to tan theta is constant. Okay. So this is going to be constant here. So graph is a straight line. Straight line. And what is the meaning of this graph, you know? It is having a uniform speed, uniform velocity, and initial velocity of this graph is 0. If this line is started from here, what is the meaning of this graph? That means it is having certain velocity 2 meters per second, for example. Already a car is having certain velocity 2 meters per second and its velocity is increasing uniformly. It is not starting from rest. Because when you are observing, the car is already having certain velocity. It is not starting with 0 velocity before you. It might be starting from somewhere else. It might be starting from certain back where you are not seeing. Understand? So this is the meaning of the graph here. Is a body starts with uniform velocity, but it's having a certain initial velocity. U is present here. V is going to increase. Understood? Okay, this is the meaning of this graph. Now I'll give you one more example of this here. For example, here, this is displacement time graph, and the graph is like this. What is the meaning of this graph? Can you tell me? I told you it is very difficult to judge directly. You just observe tan theta. So you can write here, theta is increasing. So V is also increasing. V is also increasing. So therefore, and you also know, V is equal to tan theta. So V is increasing. V is also increasing means what? It has uniform acceleration. V is increasing uniformly. V is increasing uniformly. Theta is increasing uniformly, no? Theta is increasing uniformly. That means it is not having constant velocity. Its velocity is increasing uniformly. Therefore, we can call it as, it is a case of uniform acceleration. It is a case of uniform acceleration. Clear? Okay, this is a graph which is representing uniform acceleration. I will give one more example. You have to tell me now, because there are many problems which is coming under graphs here. Now I have drawn one graph like this. What is the meaning of this graph? Can you tell me? I told you you have to judge the graph with the help of angle only. This is theta. Theta is decreasing. V is equal to tan theta is also decreasing here, because theta is decreasing means V is also decreasing. Velocity is decreasing means it is a case of negative acceleration R. It is a case of deceleration. It is a case of deceleration. V is not constant here. V is decreasing. Theta is decreasing, okay, at every place. If you draw a line like this, theta theta is going to decrease from bottom to top slowly. So theta is decreasing, v is also decreasing. When velocity is decreasing, it's case of deceleration. Okay. So these are some of the examples I have given. Some more examples I'll give you. Here. Now you have to tell me what is an example here. So displacement time graph or position time graph. I have drawn one line like this. Can you tell me what type of graph it is? Ajay? Samya? What type of graph it is? I told you to judge the graph, go for V is equal to tan 90, which is infinity. Okay. So, what is the meaning of this graph? Can you tell me now? Time is 8 o'clock. This is your house at the origin, and this is the college. At 8 o'clock you are at the college. You started at the college, and within 8 o'clock you reached the college. Within no time you reached the college. Is it possible? So this is an impossible graph. This is called as an impossible graph. It's highly impossible. Okay, I'll give an example of one more impossible graph here. For example, I have drawn a graph like this. This is displacement time graph. It is an impossible graph here. Why? For example, at 8 o'clock, which is at this point, we have observed. What are you going to see here? This is having this position and this position. At particular time, 8 o'clock, like for example, this is 12 o'clock. 12 p.m. Okay? You are seeing that your brother is at this position at 12 o'clock. Exactly. You woke up for a toilet. You have seen that he is beside you in the bedroom. You went to toilet, he is there, it's also there also he is present. Then you will go for number 2. इधर भी दिख रहा, बेडरूम में भी है, अभी तो छोड़ गया मैं, भी देखा तो टॉयलेट में भी दिख रहा नीचे. Is it possible? At one particular time, 12 o'clock at night, you are seeing the same person at 2 positions. These are the 2 positions. It's highly impossible. Impossible graph it is. Okay? That's it. So these are some of the examples to make you understand here. Next thing we shall discuss here is velocity time graph. Velocity time graph. Position time graphs we have already discussed. This is called as velocity time graph. And how are we discussing this velocity time graph? So here this is velocity and this is time. X-axis representing time here and y-axis represents velocity here in this case. So now what I am going to do here is I am drawing a graph like this. Starting position, let us imagine it is A, ending position is B. Now what I am going to do is I am drawing a dots here. And this is imagined to be T1, this is imagined to be T2. This is imagined to be V1, this is imagined to be V2 here. Now I am drawing the lines here. This is theta. This is theta, this is AB, and you can write this as C and D. Okay, so C and D here. Now, what are you going to do is in velocity time graphs, what are the things you are going to get here? Now you just remember one thing here. Acceleration, if you want to find out, acceleration is equal to slope of VT graph. If you want to find out acceleration, you have to find out the slope of the VT graph here. Velocity time graph. Slope of velocity time graph gives you acceleration. But if you want to find out displacement, what do you have to do? Area of VT graph. Okay? So you have 2 things you are getting in this graph. VT graph. It's a very important graph, a special graph here. Okay? Where we can discuss about even equations of motion can also be derived by using this graph. So it's a special graph where we'll get 2 physical quantities. One is an acceleration, another is displacement. Okay? How? So acceleration, if you want to find out, you have to find out the slope of the graph. If you want to find out the displacement traveled by using this velocity time graph, you need to find out the area of the graph. Okay, I'll give you an example for acceleration first of all. So acceleration is equal to slope, which can also be taken as tan theta. So here, acceleration, initial position of this graph is this one here, which is time t1, and time t1 speed was v1, which is called as initial velocity here. Initial velocity. Time t1 velocity is v1, and time t2 velocity has been increased to v2 here. So acceleration is equal to slope, which is taken as tan theta, and this tan theta is taken as opposite side is BC, adjacent side is AC here, which can be taken as BC is V2 minus V1 by T2 minus T1. Therefore, acceleration is equal to delta V by delta T. In terms of differentiation, you can write this as dV by dt. Okay? So change in velocity with respect to time is called as an acceleration. Okay? But if you want to find out the displacement, you have to find out the area of the graph. Area of the graph. Now, see here, I will discuss about equations of motion by using this graph here. Okay? So how I am going to say, how I am going to prove this one, just see. So acceleration is equal to delta V by delta T, that is V2. What is that we are getting now? Just see. Acceleration you have to find out, no? So I will take this point from here to here as initial velocity. Is it the initial velocity? From here to here it is taken as initial velocity, let us imagine. Okay. So from here to here, let us imagine it is going to be the final velocity. This is considered to be final velocity, this is considered to be initial velocity, what I have said here. Okay. And from here to here it is imagined to be a time t. Is it? If this is v from here to here and this is u from here to here, then what is BC? BC can be u minus, that is v minus u. Can you write this as v minus u? Can you take BC as v minus u here? So acceleration is equal to BC by AC, which is v minus u by t. So therefore v minus u is equal to AT. V is equal to u plus AT. So I have derived the first equation of motion by using this graph. By using slope I got acceleration. By using slope I got acceleration. But how can I find displacement here? I have proved v is equal to u plus AT by using this graph. But can I prove displacement by using this graph? Yes. So displacement, that is ut plus half AT square. Okay, I just told you that you have to find out the displacement means you have to find out area of graph below AB. That means displacement is area of triangle ACB. Okay, so area of triangle ACB plus area of rectangle ACD. Okay, so displacement is equal to, first area of rectangle you can consider it as length into breadth plus this is half into base into height. So length into breadth is nothing but, what is the length of the rectangle which is below? Can you tell me now? Length is u and breadth is t. Okay? Yeah, breadth is v, whatever it may be. Length into breadth or breadth into length, whatever it may be. So u into t you write. So half into base. Base is t. And what is height of the triangle? Height of the triangle is BC, right? What is BC here? V minus u. Okay? But A is equal to V minus u by t. Can you write V minus u as AT? Okay? Substitute here. This here now. So S is equal to ut plus half t. V minus u can be written as AT. S is equal to ut plus half AT square. Got the third equation of motion also? Yes. Got the third equation of motion also? No, sorry, second equation. Now, you have to find out the third equation of motion. What is that? That is v square minus u square is equal to 2as. In second equation of motion also you have got the graph. You have found the area of a graph. But here also you can find out the area of a graph, but in a different way. How? That is, we shall discuss here. So, displacement is equal to area of trapezium ADEB. ADEB. I am taking the area of this graph only. Area of the graph below AB only I am taking. Instead of taking separately triangle and rectangle, combined together I am taking a trapezium. Trapezium means it is a quadrilateral in which two sides are parallel. A quadrilateral in which two sides are parallel, that is called as trapezium. Okay? So to find out the area of a trapezium, what is the formula? Can you tell me now? Displacement is equal to half into sum of parallel sides into distance between them. Okay? Half into sum of the parallel sides into distance between them. So you will just apply the formula here. S is equal to half. Sum of the parallel sides are nothing but EB plus AD into distance between them is AC. AC is the distance between the two parallel sides, or DE is also the same. Is it?
Yes, sir.
So you can write like this now. Displacement is equal to half. What is EB?
T.
EB is V plus AD. AD is U. Okay? And what is AC? AC is T. But A is equal to V minus U by T. That means T can be taken as V minus U by A. Yes? You just substitute this value here. This value in this formula. That's it. Then what are you going to get? S is equal to half into V plus U. V minus U by A. Then S is equal to A plus B into A minus B is V square minus U square by 2A. This implies that V square minus U square is equal to 2AS. Okay? So this is the third equation of motion. For fourth equation, we need not draw any graph. There is no graph for fourth equation. Displacement traveled in n second. But in applications, you can use that fourth equation. I'll tell you where you can use it. Understood? Okay? Now we shall start here the remaining part. You all know that V is equal to U plus AT, S is equal to UT plus half, AT square, V square minus U square is equal to 2AS, Sn is equal to U plus A into N minus half. So these are all equations of motion, but you have to convert this into motion under gravity. Okay? So how are you going to convert if in the case of motion under gravity? So let us take motion under gravity. What is the meaning of this motion under gravity? For example, if a body is dropped from a certain height, its initial velocity is 0 and acceleration is going to be plus g because it is coming downwards, and displacement is taken as height. If it is the case of vertical motion, we consider this as a height here. Okay? Vertical motions are always considered to be heights, is it? Yes, it is going to be height here. So what are the changes we need to do here in the above equations? Here, for example, a body is coming down here. If the body is moving up, there's a special case which is moving up here, this is going to be the ground. Here, A is going to be minus g, final velocity is here, which may be 0 or sometimes after going to be the maximum height. Okay? So it is going to be the maximum height, it is going to be 0. So A is going to be minus g. So what are the changes here? Changes between this motion in a horizontal motion and motion under gravity, vertical motion. So the changes are only two. A is written as plus or minus g. S is going to be written as h here. Okay. So then I can write the above equations like this. V is equal to u plus r minus gt, and h is equal to ut plus r minus half gt square. V square minus u square is equal to plus r minus 2gh, and this is taken as hn is equal to u plus r minus g into n minus half. Okay, so g into n minus half. These are going to be the equations of motion under gravity. Okay, so now let us find out some of the things by using these concepts here. What are the things you need to find out by using these concepts? Let us see. So here, by using the concepts which I have written there here, first thing is you have to find out what is time of ascent. Okay, we shall discuss about what is time of ascent. See, time of ascent is given by TA. What is the meaning of time of ascent? If a body is thrown upwards, how much time it has taken to reach the maximum height? How much time it has taken to reach the maximum height here? Okay, so let us take here. You have thrown the body at this point. It has reached the maximum height. Now, what formula is suitable here? Time of ascent. If a body is thrown upwards, how much time it has taken to reach the maximum height? So one thing it is clear, there is no discussion of displacement, or what is that? There is no discussion of height here. So each and every formula is having certain speciality here in this case also. And there is no discussion of height here. Okay, there is no discussion of height in this case. There is no discussion of final velocity in this case, and there is no discussion of time in this case. When there is no discussion of height here, which formula to be selected? Yes, the formula to be selected is when there is no discussion of height. V is equal to u plus r minus gt. This is the formula to be selected. But it is clear that it is going to be above, it is going toward against to the gravitational force, and that's what is taken as minus g here. Okay, minus g here. So V is equal to 0, A is equal to minus g. T is taken as TA, time of ascent, time taken by a body to reach the maximum height from the point of projection. That's it. So what are you going to do here? What are you going to do here? In this case, 0 is equal to u minus g into TA. G into TA is equal to u. TA is equal to u by g. This is called as time of ascent. Time of ascent. Okay. So we shall find out what is maximum height. Maximum height means what? Let us take it as capital H. How much distance it has travelled from point of projection to the point where it is going to stop there. Final velocity is 0. So distance travelled vertically by a body from the point of projection, that is u, to the maximum height, that is 0 here. So that is, you can take this displacement as capital H. In this case, maximum height is represented with capital H, and you all know that A is taken as minus g, and it is clear that there is no discussion of time here. There is no discussion of time here. Throwing a body to the maximum height means initial velocity will be there, final velocity will be 0, and displacement is there. There is no discussion of time here. The formula to be selected when there is no discussion of time is v square minus u square is equal to 2 plus or minus 2gh. But in this case, what are the changes you need to do here? The changes 2as, this one, okay, 2a, okay, no problem, 2gh. So changes you have to do here is s is equal to capital H you can take, and final velocity is going to be 0 here, okay, that's it, and A is going to be minus g in this case, not plus g, it's taken as minus g. So final velocity is going to be 0, so 0 square minus u square is equal to minus 2g into capital H. H is equal to u square by 2g. H is equal to u square by 2g here. Why u square by 2g? Because minus minus gets cancelled here. So you can take it as u square by 2g. That is called as maximum height. Okay. So now, what is the next thing we need to find out here? For example, here in this case, if you observe here, you can find out two things. Okay. You can find out maximum height in different way also. For example, a body is dropped from this position. So that is also maximum height only, no? When you are dropping a body with certain height, that is nothing but the maximum height only. It comes downwards. it strikes the earth with certain velocity, final velocity here in this case. So there is no discussion of time here. Sorry, what is that? I'll tell you one thing here. So when a body is dropped from certain height, it strikes the ground, but we don't know with how much speed it is going to strike. We don't know with how much speed it is going to strike. That's why there is no discussion of final velocity. Because while you are dropping, we are unaware that with how much speed it is going to strike the ground. The formula you have to select is H is equal to ut plus or minus half gt square here. So in this case, you all know u is equal to 0, a is equal to plus g because it is coming to downwards here, and s is equal to capital H, and t is taken as td. Time taken to reach the downwards, time taken to reach the ground is taken as time of descent. Time of descent. And you all know what is the meaning of time of descent. Time of descent is nothing but time taken by body to reach the ground from the top, from the point of dropping. From the point of dropping. Then this is taken as h ut plus half gtd square. So u is 0 here. U is going to be 0 because you are dropping at this point. U is going to be 0. So you can write this as h is equal to half gtd square. Okay. So you just take this formula here. This is taken as 1. This is taken as 2. Both the formulas are giving maximum height only, because when you are dropping from the ground, it reaches to the maximum height, but from there again it returns back. Understand? And returning back distance also same, h only. So what are we going to do now? So 1 will be equal to 2 here. 1 is going to be equal to 2. Half gtd square is equal to u square by 2g. So 2 gets cancelled here. Td square is equal to u square by g square. So Td is equal to u by g. So you're getting Td, time of descent is equal to u by g. With this it is clear that time of ascent is equal to time of descent is equal to u by g. Time taken by a body to reach the maximum height and time taken by a body to reach the ground from the maximum height is going to be same. In how much time it is reaching the maximum height, the same time it is going to reach the ground if there is no air friction. If there is no air friction. Understood? So this is the concept here. Next, velocity, initial velocity and final velocity of a bodies we have to discuss here. Now, what is the meaning of final velocity? When a body is dropped from certain height, it reaches the ground and strikes the ground with certain velocity. Find out that velocity. In this case of initial velocity, when a body is thrown upwards with certain initial velocity, it has to reach the maximum height, it has to become 0. You have to find out the initial velocity as well as final velocities in both the cases here. How are you going to find out? So in both the cases, one thing is common here. No discussion of time. There is no discussion of time in both the cases. So write v square minus u square is equal to plus 2gh here, because acceleration is equal to plus g. In this case, acceleration is equal to minus g. So here you will write v square minus u square is equal to minus 2gh. But the difference here is what? Here u is equal to 0, here v is equal to 0. Is it? That's it, no? So right now, v square is equal to plus 2gh. V is equal to square root of 2gh here. But in this case here, 0 square minus u square is equal to minus 2gh. Here u is equal to square root of 2gh. With this it is clear that u is equal to v is equal to root 2gh. What does it mean here? With how much speed you are throwing a body from the ground, with the same speed it returns back and strikes the ground. Clear? Understood? Okay. Now just see here. This is the tower. And you are throwing a body upwards. And this is reaching the ground here. Okay? So this much, this is going to be the height of the tower here. From this, we are throwing a body upwards. Then what is going to happen? Let us see here. Generally, you write the formula h is equal to ut plus half gt square. This is going to be the formula, is it? This is going to be the formula here. Okay. But here, this much height is to be subtracted, no? This much height of the tower is to be subtracted here now, because you are not throwing from the ground, you are throwing from certain height. Okay, so this is the formula you'll write when you throw a body from ground, where you'll take it as minus here. Is it? Minus, no? A is equal to minus g you'll take. A is equal to minus g. But here in this case, you are throwing a body from certain height. That means this height should be removed from the scene here. So right now, minus h is equal to ut minus half gt square here. This much height is to be removed. Then what happens? This minus, if you send that side, it is going to be half gt square minus ut. Okay? This is the formula we have to use when a body is thrown from a certain height. Body thrown from certain height. Okay? So this is the formula you have to use. Next.